This says no real roots. So let's find out what that really means. And as we look at this first setup, one of the things I suggest you might want to think about is where is it symmetric? And by choosing where it's symmetric, you can kind of better establish which starting points. So here's negative b over 2a, and I'm doing this in red because maybe you do this in your head. Negative 1 would be 1 over 2 times 1 would just be 1/2. And knowing that the symmetry is at 1/2, maybe that means I'm interested in values that are around that area. So I know that 0 is right by 1/2. 1's above it, negative 1 is back, and maybe I go up to 2. And there's negative 2. So I have, about 5 points. This won't be perfectly symmetric because of the fraction deal. So we're going to steer clear of using fractions to do this. Now, you have gotten good at plugging in values by this point, and because of that, I'm just going to complete the table, and you can get caught up. This gives us our table, and based on what I'm saying, I think I'd like to go and graph this, still labeling everything as I do. Back 5, forward 5, 1, 2, 3, 4, 1, 2, 3, 4. Accurate enough to show what I need, but not obsessive on this graph. 1, 2, 3, 4, 1, 2, 3, 4, 2, 3, 4, 1, 2, 3, 4. And when I go to plot these, you can get caught up too, so pause this video and go ahead and graph these on your own. Try and keep your graph a little bit neater than mine. Be forgiving of the fact that I'm using this app. And also notice that, here's where the two values were repeated, and that means that our axis of symmetry would be right about there. And now the deal is here, I wanted this to be accurate, didn't I? And for my purposes right here, it's accurate enough to show me that there aren't any roots. If I was interested in something like the y-intercept, it might require a greater amount of detail. Now with this one we already knew the y-intercept because the value of x is 0 there. And I point all this out because as we move forward, you're going to have to be really flexible with these, just like you were with the factoring chapter. And you really want to be flexible in knowing why you're doing what you're doing. So when to and when not to cut certain corners. So here's y is x squared minus x plus 4 is 0. It's always a nice thing to go ahead and label those graphs. So as we look at this, there are no real solutions, no real number solutions for this. So that means that if I try to get this quantity on the left equal to 0, it's just not happening. Make this one an on your own problem, and you can use Wolfram Alpha to check it and see if it looks alright. But these are no real roots problems, so the assumption is going to be that it's not going to graph nicely. Moving on. Use factoring to determine how many times the graph of y equals x squared plus x minus 12. Now in the last couple chapters we haven't really seen f of x in a while, but remember that that is the function of x. And the purpose behind that is maybe for some situation you want f of x, and then for another situation you want g of x. But it's just another way of writing y. And the nicer thing about it is that it really communicates that this is the input, while f of x is the entire output. So if you need a little review on that, see me and we'll talk about it. Now we're interested in how many times this graph intersects the x-axis. So this whole section here has been about solving by graphing, but now it looks like we're going to solve this by graphing. And really it never tells us to graph it, so in the notes I will quickly mention how this can be graphed too. So let's go ahead and rewrite the entire function, and we will write it with f of x equals x squared plus x minus 12. If you prefer to see it in terms of y, you can, but we are going to end up setting up 0 over here on the left side because we know that for those values of 0, that's where the function that either opens downward or upward would end up running into my x-axis. So that's what it's saying, intersecting the x-axis. So we set it equal to 0 because that's where it's going to intersect the x-axis. And I'm looking for the factors of negative 12 that add up to positive 1 because there's no a in front of this. So I'm going to write x plus 4 times x minus 3. And what this means is that I have values where y will be 0 at x is negative 4 as well as 3. So these are the solutions I got from there. And that's going to tell me that it will intersect the x-axis twice. So we'll write that. The graph intersects the y-axis at x equals negative 4 and 3. So since they have this as more of a word type problem question, we'll throw that in there. So the graph intersects the y-axis twice at x equals 3 and x equals negative 4. Give yourself a moment to write that down, and let's do one more example. Go ahead and pause this. Do it on your own if you feel comfortable, and I will talk quicker through this one. So the function of x is x squared minus 10x plus 25, and again the left side will set to 0. In the same step, there's no reason we can't find the factors of 25 that add up to negative 10. And since this repeats itself, we really only have the intersection happening here. So I would say the graph intersects the y-axis just once at x equals 5. And something to think about here. You know, a lot of times there's very specific things that you want to use from your teachers, like x is the element of all the real numbers. That's something that's pretty standard and consistent in conversation, but this is going to definitely be more loose. So obviously, don't force yourself to try to memorize verbatim, meaning word for word exactly what's being said there. And here's the deal. This intersects the y-axis. What this means is that at positive 5, this graph is touching this graph is touching the x-axis just once. It is not crossing it only once. And the reason it's not crossing it only once is because this graph barely touches it. The only way I would cross it is if it happened twice, because this shape is a parabolic shape. It's a quadratic function. Otherwise, if it touched just once, it would have to have a different sort of appearance. And that wouldn't be the same as something that had a square on it. This is the second video. There's going to be one more for a couple of different types of problems.